Hey there, curious minds. Ever wonder why some AI systems sound super confident, like, I'm 99% sure this is a cat, but then they're totally wrong? That's where calibration comes in. It's not just about being correct, it's about being reliably correct. Today, we're diving into a breakthrough that's making AI models more trustworthy, by teaching them to know when they're sure and when they're not. Let's start with a simple example. Imagine a weather app that says, there's an 80% chance of rain. If it actually rains only 50% of the time when it makes that prediction, the app is overconfident, it's miscalibrated. Now picture this in AI. A medical tool says, this scan shows cancer with 95% confidence, but the patient is fine. That's not just a glitch, it's a crisis of trust. For years, researchers tried to fix this. They used three main approaches. 1. Intuitive tweaks, like adjusting confidence scores by hand, but this felt more like guesswork. 2. Binning grouping predictions into ranges, e.g., 80-90% confidence, and adjusting them to match real outcomes. But this could backfire if the groups were too broad or too narrow. 3. Mathematical formulas, theoretical models that theoretically align predictions with reality. The problem? They often assumed perfect data or models, which rarely exists in the real world. These methods had big flaws. Some were too simplistic, others required retraining the entire model, which is time-consuming, and many couldn't handle messy, real-world data. Enter h-Calibration, a breakthrough framework that fixes calibration after the model is trained, without needing to retrain it. Think of it like adding a reality check to the model's predictions. Instead of forcing perfect alignment between confidence and reality, which is often impossible, h-Calibration sets error bounds, a safety margin that ensures the model's confidence stays reliable, even if it's not 100% perfect. Here's how it works. The researchers created a probabilistic learning framework that mathematically guarantees the model's confidence scores stay within a controlled error range. Unlike older methods that either overfit to specific data or rely on shaky assumptions, h-Calibration adapts to different scenarios. It's like having a GPS that doesn't just tell you the fastest route, but also warns you when the map might be outdated. Now, how do we fix calibration? The answer lies in calibration mappings. Think of them as adjustable dials. There's the linear dial, which gently nudges confidence levels in a straight line. Then there's piecewise, which splits probabilities into zones. For example, if an AI says it's 60-80% sure, we tweak it a little. But if it's 90% plus, we get more cautious. And then there's nonlinear, which lets us make wilder, more precise adjustments. It's like having a toolkit for fine-tuning AI's self-awareness. But here's a sneaky trick to keep things fair. K means clustering. Imagine sorting data into groups, some tight, some spread out, and giving each the same attention. This stops AI from obsessing over rare, noisy data points, which can distort results. It's like a teacher grading every student equally, not just the ones who shout the loudest. And the proof? In 15 different tasks, h-Calibration beat the competition. From identifying cats in photos to predicting complex patterns, it's a game changer. But the real challenge? Generative AI, like chatbots or art-making tools. These models don't just classify, they create. And their hallucinations, when they make up facts, are tied to overconfidence. Small changes, like training them with instructions, can mess up their confidence levels. But techniques like temperature scaling, think of it as a volume knob for certainty, are already helping. Our work is paving the way to apply these fixes to the next generation of AI. So why does this matter? Because better calibration isn't just about numbers. It's about building AI that's not just smart, but honest. Imagine a world where AI admits when it's unsure, or where chatbots stop inventing facts. That future is closer than you think. Thanks for watching, stay curious, and let's keep building a smarter, more trustworthy AI together.